Okay, so we're still talking about triangles. What is the sum of the interior angles of a triangle? Sum of the interior angles of a triangle. 180, that's right. So we worked with the interior angles of a triangle before. We've talked about exterior of an angle, but not really exterior angles with regard to a triangle. And that's what we're talking about today. So it says an exterior angle of a triangle is formed when one side of the triangle is extended to create an angle outside the triangle. So for example, this is a triangle. This side, they extended past that side. Number 4, angle 4 rather, is an exterior angle. Are you with me? Okay, so our phones do need to be put away now. I know you guys had them out a second ago, but we do need to put them away now. If we need to, I'll let you get them back out, but I don't think we're going to need to. So make sure you circle 4. Make sure you indicate that that's the exterior angle. 1 and 2 are interior angles, right? So let's look. It says here, every triangle has 6 exterior angles. 6 exterior angles. That means on every side of the triangle, you could create 2 exterior angles. So let's look at those. So if we take this side of this triangle and we extend it past, if we start here at angle 2, or not angle 2, the inside here, if we start there and extend that side, we create angle 4. That's an exterior angle. If we start here at this angle on the triangle and extend that side, we create this exterior angle, angle 3. These are not the measures of these angles, they're just names, right? This vertical angle to one of the angles in the triangle, that is not an exterior angle. It's important that you know that. So this side, if you extend from angle 2 this way, all the way past the triangle, you're going to create this exterior angle. So make sure you go ahead and circle the nose, like I did. Underline the exterior angles, like I did. Go ahead and close up your Chromebooks if you still have them open. All right, so exterior to the triangle, right? So now we're going to learn a rule about that. The measure of an exterior angle, so that would be angle 4, is equal to the sum of the 2 remote interior angles. So what do you think? So 1 and 2 are the only angles that's labeled here. So it's going to be They did. Okay. Thank you. I do appreciate the star video. Tina's kind of right here, so okay. I don't know. He didn't say, but you can see that. Okay. So, what does the word remote mean just in normal conversation? Something is remote. What do you think of, Xavier?
Kind of like in the middle of nowhere, like kind of just there.
In the middle of nowhere. What do you think, Helen? Isolated, out by itself in the middle of nowhere. Typically in the middle of nowhere means there's nobody else around it, right? So remote interior angles means it's far away from that exterior angle. The exterior angle is remote from these 2 angles, and if we'll just remember that this exterior angle, the 2 remote angles are the angles not touching that exterior angle, right? So angles 1 and 2, those are the remote interior angles. Does that make sense, Daria? Okay. Does that make sense, Miles? Okay. So angle 1, angle 2, not angle measures, just these are names. So what we're saying is, if you add these 2 angles together, you get the exterior angle to those 2 remote angles, right? So angle 1 this angle and this angle, if we drew an exterior angle out here, we could have different remote angles depending on which exterior angle we're talking about. Does that make sense, Vivian? Okay. So let's look at this first example. I can make it a little bigger. So for finding the value of x, so x is the exterior angle, right? So the exterior angle measure in this example is x. These two angles don't touch the exterior angle and they're interior angles. That makes these two angles the remote angle measures relative to this exterior angle, okay? They're not always remote angles to all the exterior angles, but to this exterior angle they are. So given that these are the two remote angles to this exterior angle, we just learned that if we add those two remote angles under the exterior angle theorem, then we know what the measure of that exterior angle is. So all we got to do is add those two remote angles, and now we know that this angle measures 146. Okay? Any questions on that one? So we already learned how to solve for that angle, right? We've been using a linear pair for that, and we could still do that. But that linear pair rule is why we can use this exterior angle theorem. That is really where this theorem comes from. All right, so look at an example. Any questions on example 1? All right, look at example 2. We're going to find the value of x. Is this angle marked x degrees? Is that an interior or exterior angle? It's interior, right? So there's one exterior angle marked out here. So the exterior angle on the outside of the triangle is here. It's measured at 120 degrees. So what are the measures of the remote angles? What are the measures of the remote angles? What would you say? Thomas? Well, we have two angles marked in there with it labeled, right? Give me the one you're confident about.
120.
That's an exterior, right? The remote angles are the interior ones.
53.
Yeah, 53 is one. Now, x is a variable, but it's also the measure of this angle, right? So x and 53 are our remote angle measures. So we learned that the exterior angle is equal to the sum of these two. So here we were looking for the exterior angle. Now we know the exterior angle. We know the exterior angle is 120 degrees, and we learn now that rather than go through the whole linear pair and subtract them, we can just add these together, and then we could solve for x that way. We subtract 53 from both sides. Now we know that x is equal to 67. And this is what it's going to look like on your, on Alex. All right, caught up? Questions? Okay. So, given this diagram, and you won't have them marked, they're going to be marked angle 1, angle 2, angle 4, and angle 3. These are not the angle measures. Someone asked that question second period. It was a great question, but it's not, those are just labels, right? It tells you here, suppose the measure of angle 2 is 31, so let's label it 31. It's always a good idea to mark our given information on our diagram. We're going to mark it angle 4 is 78 degrees. Given that, it says, this is just like an example on your assignment today. So the sum of the interior angle measures of a triangle must be what, Miles? The sum of the interior angle measures of a triangle must be what? 180. Yes, 180. So now we know that the measure of angle 1, the measure of angle 2, and the measure of angle 4 equal what, Morgan? Morgan? So this angle plus this angle plus this angle has to equal what? Yeah, that's all. Sometimes when it seems too easy, it's confusing, I know, but it is too easy at this point. All right, so if it says we are given that the measure of angle 4 is 78, so the measure of angle 1 plus the measure of angle 2 has to be equal to what? Well, it's got to be equal to the measure of angle 3, right? We know the measure of angle 3 is 180 minus 78. So the measure of angle 1 plus the measure of angle 2 has to be equal to 102. We're kind of deriving that theorem, why this theorem works, why we can take that shortcut here. Just from the figure we can see that the measure of angle 3 plus the measure of angle 4 equals, and for the sake of time, we keep putting 180 in there. So since the measure of angle 4 is 78 equals 78 degrees, it must be that the measure of angle 3 equals 102. So now we know that the measure of angle 3 is equal to the measure of angle 2, and we know that because of the exterior angle property of triangles, which says for any triangle, the measure of its exterior angle is equal to the sum of the remote interior angle. And that's literally one of your problems. So any questions? Okay. Caught up with me? Not quite? Okay. So just so you know, somebody was mad at somebody at another school around here, and so while I think your video said it was pretty close.
Someone just wants a video like how much it costs to take your section off of parking.
Yeah. Nobody's mad at anybody on our campus, so they're not trying to get on our campus. I'm just trying to reassure you a little bit, right? Nobody's mad at us. Okay. All right, we're going to move on. So this is the diagram we would see. It won't have boxes there. I boxed those because I filled in those. But we want to find the measure of angle x. Is angle x an exterior angle to this triangle? Is the measure of, so is this angle that has a measure of x degrees, is this an exterior angle? It is not. Very good. But it is a what kind of angle to this angle? Vertical. Good job. It's a vertical angle. So if we can figure out the measure of this angle, it's congruent to this one, right? So that's what our goal is. So we are going to consider that this is an exterior angle. This angle and this angle are remote angles to it. Does that make sense, Mayal? Does that make sense, Elizabeth? Okay. So it's outside. The two angles that aren't touching it are this angle and this angle. So we know that this angle plus this angle equals 110. And we know this angle and this angle have the same measure. So if we say x plus 53 equals 110, then we can solve our equation. Does that make sense, Morgan? You tilted your head. So these are two remote angles, right? We don't know this one, but if this one is x, then this one is x as well, right? Because they're congruent, right? So this angle plus this angle, two interior angles that don't touch this angle. That makes them remote to that angle, right? So this angle plus this angle has to equal this one. So if we subtract 53 from both sides, Now we know that this x is 57 degrees, right? And this angle and this angle are congruent, so the x we're looking for is also 57 degrees. Does that make sense, Charlie? Okay. Any questions on that one? Okay. So let's look a little bit. We've got another pair of vertical angles here, but that's not a variable we're looking for. But we know that this angle and this angle are congruent, so I'm just going to go ahead and mark that. This is an exterior angle. If I know this angle and this angle, I know they're going to equal 1/12. Does that make sense, Devanshi? Okay. So can I figure out what this angle is? If I can figure out what this angle is, I can say x plus this angle equals 1/12, right? Anybody have an idea of how I could figure out what this angle is? Go ahead. As which one? It would be the same as 1/12. Why? What makes you think it's the same as 1/12? So I'm asking you, what could our strategy be so we could find the value, the measure of this angle here? It's 1/12. So how'd you get it? So what were you gonna say, honey? 1/12 minus 42. What do you think, Amaria? What do you think, Xavier?
What are you trying to find again?
Well, we're trying to find the measure of this angle. We know this angle, x, plus this angle equals 1/12.
Okay, so
How can we find the measure of this angle?
we have to find the other angle right next to it.
So that would be the linear pair. It's the angle that's part of that linear pair. Okay, how would you do that?
You would add 31 and 42,
Okay.
and then you would subtract it, or you would subtract 180 by the sum of.
So when you add those together, they're 73. So if you subtract them, then that's 107.
And then you subtract 180 by 107.
For that linear pair there, which now we know that that's 73, right? So now we have two remote angles. This one we don't know. This one we do know. So we could write our equation, x plus 73 equals 1/12. Right? Does that make sense, Elizabeth? Okay. So we subtract 73 from both sides. Now we have the measure of that angle, and that angle is the one they're talking about right there. It would be 39. What do you think, Ashlyn? Does that make sense? Okay, great. All right. Everybody caught up with me? All right, let's keep going. All right, this is not so much exterior angles, but so this is a 6-0 unit or section, kind of getting us ready for the rest of this chapter. So we're reviewing some things. What does this little square in the bottom right-hand corner here mean? I couldn't hear. Somebody raise your hand and let me an answer. Kelly? It's a right angle. What's the measure of a right angle, Ashlyn? 90 degrees. What if we add angle E, angle C, and angle D together? What are they going to equal? 180, right? So we know that this is 90, so we can add all three angles together and write an equation. 4x minus 2, well, it doesn't matter the order. Here I have 3x plus 15 plus 4x minus 2 plus the 90-degree angle equals 180. I use parentheses here just as grouping symbols. It's descriptive. They don't mean anything. We don't need them. all right? But you can see now this is angle 1, angle 2, angle 3, I think, are the three angles of the triangle. Now we're just going to solve this equation. We're going to combine our like terms, 3x plus 4x, 7x. We're going to add our constants, 15 minus 2 plus 90, and then it's equal to 180. And now we're going to solve this equation. We should all be able to solve it. We're going to subtract 103 from both sides. 7x equals 77. We don't have the x by itself yet. It's being multiplied by 7, so we're going to divide both sides by 7. And now we know that x is 11. They did not ask us to find x, so we have to find x to find the measure of the angle if I could ask us to. So we already know the measure of angle E is 90 degrees. It's a right angle, that's what it means. The measure of angle C, we're just going to take 11 and replace the x. So instead of 4 times x, it's 4 times 11 minus 2, and that's 48. Oh, I did the wrong one, my bad. That's 42. So the measure angle D. 4 times 11 minus 2, 44 minus 2 is 42. The measure of angle C, 3 times x, we're going to replace that with 11. 3 times 11 plus 15, 33 plus 15 is 48. 48 plus 42 plus 90 is a quick check. That does equal 180. So that is a reasonable, these are reasonable measures for the angles. If when you added them together they didn't equal 180, you'd know something had gone awry, right? We have to go back and find our mistake. Any questions? Anybody? Ready to move on? Got one more. Okay. In the triangle, suppose the measure of angle A equals x plus 6. The measure of B equals 4 times x minus 2. And the measure of angle C equals 3 times x. This looks like this is from Alex. You're going to have a problem that looks like this as well. The first thing you're going to do is write the equation in the problem. And these are just interior angles, nothing funny, no funny business here. Angle C plus angle B plus angle A equals 180, right? I did not put grouping symbols here. You don't need grouping symbols. I purposely did it both ways. They mean the same thing. So A says write the equation. B says find the measure of each angle. In order for us to complete part B, we have to solve for x. So that's what we're going to do. We're going to combine our like terms. 3x plus 4x plus x is 8x. Negative 2 plus 6 is positive 4, and that equals 180. Subtract 4 from both sides is the next step to solving that two-step equation. So now we have 8 times x equals 176. Undo the multiplying by 8 by dividing both sides by 8, and we find that x equals 22. It says write an equation to find x. There's not a spot for us to enter x anywhere, okay? But we're going to use x, where we're going to replace x in these expressions that represent the measure of these angles. So if we look at the measure of angle A, it's x plus 6. So it's 22 plus 6. Measure of angle B, 4 times x is 4 times 22, minus 2 is 86. And finally, the measure of angle 3 is 3 times x. So instead of x, we're going to have 3 times 22, and that equals 66. So you can double check that you have it, more than likely have it correct, by adding the 3 angles. And confirming that you do have the correct answer.
Good afternoon, teachers. We are still in a closed campus. Again, we are still in closed campus. The bell should be ringing in less than 5 minutes. Please go ahead and transition to the next class